In 1965, when the picture went out, you didn't take your television anywhere. A man came to your house, he opened a case in your living room, and worked on a machine running 25,000 volts through a glass tube 18 inches from your family sofa. These are the 15 tools he carried. Subscribe before we start. Number 15, screwdriver set, not just Phillips and flatheads. The TV repairman carried plastic-tipped alignment screwdrivers that looked like toys. They were made from nylon or fiberglass, and they existed for one reason. A metal screwdriver inserted into a tuned coil changed the tuning just by being near it. The metal affected the magnetic field. A plastic tip didn't. The repairman could adjust a coil slug without detuning the circuit he was trying to tune. No other trade in America used non-metallic screwdrivers. These were unique to electronics repair. Number 14, diagonal cutters and needle nose pliers, standard hand tools, nothing exotic. But inside a TV chassis with 100 components soldered to terminal strips and turret boards, space was measured in fractions of an inch. The needle nose pliers were the only way to grip a wire, hold a resistor, or steady a component lead while the soldering iron worked next to it. The diagonal cutters trimmed the lead flush after the joint was done. These tools lived in the bottom of the caddy and came out on every single call. Number 13, soldering gun and solder. A portable soldering gun, usually a Weller with a built-in light on the tip, and a roll of rosin core solder. When the repairman found the bad component, he unsoldered the old one and soldered the replacement in place, in the customer's living room, on the customer's carpet, with a 400-degree iron inches from the wood veneer of the cabinet. The smell of rosin flux and hot solder was how you knew the TV man was working. Every kid who grew up in the 1950s and 60s remembers that smell. Number 12, fuse assortment. A small plastic box of glass AGC fuses in every common amperage. A blown fuse was the very first thing a repairman checked because it was the cheapest and fastest diagnosis. Pull the back off the TV, find the fuse holder, check the element. If the glass was clear, the fuse was good, and the problem was somewhere else. If the element was burned through, the repairman popped in a replacement and turned the set on. If the new fuse blew immediately, the problem was downstream. A shorted component pulling too much current. The easy answer was gone, and the real work started. Number 11, mirror on a stick. A dental-style inspection mirror on a telescoping handle. A console television in 1965 weighed 200 pounds or more, mounted inside a wooden cabinet that sat against the wall with 6 inches of clearance behind it. Moving the set was a two-man job. The repairman used the mirror to look behind the chassis, between the cabinet wall and the circuit boards, at tube sockets, wiring, and solder joints he couldn't see from any other angle. The mirror was the first tool out of the caddy, and the reason a 200-pound TV didn't have to be pulled away from the wall on every call. Number 10, cheater cord. An AC power cord with alligator clips on one end and a standard wall plug on the other. When the repairman removed the back panel of the TV to access the chassis, the safety interlock disconnected the power. The set went dead. The cheater cord bypassed the interlock, feeding power directly to the chassis, so the repairman could run the television with the back off and every circuit exposed. 300 volts of B+ DC on the power supply rails, 25,000 volts at the picture tube and node cap, all of it live, all of it exposed, 18 inches from the repairman's hands. The cheater cord was the most dangerous tool in the caddy because it removed the only safety feature the television had. Number 9, VTVM, the vacuum tube voltmeter, a test instrument about the size of a hardcover book with a large analog meter, a rotary selector switch, and a pair of test leads. The VTVM measured voltage, resistance, and current in tube circuits. What made it different from a standard multimeter was its input impedance. It drew almost no current from the circuit being measured, which meant it didn't change the voltage by measuring it. A standard meter would load a high impedance tube circuit and give a false reading. The VTVM gave the real number. Every television repairman in America owned one. It was the most important diagnostic instrument in the Caddy, and a man who couldn't read a VTVM couldn't fix a television. And this is the tool that most people in America actually use themselves. Number 8, tube tester. A device with rows of tube sockets across the top, a set of selector switches, and a large meter that read good, weak, or replace. The repairman pulled every tube out of the TV, tested each one in the tester, and replaced the ones that failed. Tubes were the most common point of failure in any television because they aged, filaments weakened, cathode emission dropped. Gradually the picture dimmed, the sound distorted, or the set stopped working altogether. But the tube tester wasn't just the repairman's tool, it was everyone's tool. Hardware stores, drugstores, and supermarkets across America had self-service tube testing stations where any man could walk in with a paper bag full of tubes, test them himself using a chart taped to the machine, and buy replacements from a display rack right next to the tester. The TV repairman's core business, the house call to test and replace tubes, started disappearing the moment those machines showed up in every store in the country. A man who could test his own tubes didn't need to pay someone to drive to his house and do it for him. The tube tester was the most important diagnostic tool the repairman carried, and it was also the tool that taught America to do his job without him. Number 7, high voltage probe. A heavily insulated wand about 18 inches long with a test lead on one end and a pointed tip on the other. The probe measured the anode voltage on the picture tube, 10 to 25,000 volts of DC, stored inside a glass envelope the size of a dinner plate. A standard VTVM test lead would have arced through and killed the repairman. The probe divided the voltage down by a factor of 100 before it reached the meter, so 20,000 volts read as 200 on the dial. The repairman slid the probe under the rubber anode cap on the side of the picture tube and read the number. Too low, and the screen was dark. Too high, and the tube was being damaged. This was the only tool in the Caddy that measured something capable of killing a man from a foot away. Number 6, capacitor checker. Electrolytic capacitors were the second most common point of failure in a television after tubes. They dried out. The electrolyte inside the can evaporated over years of heat. The capacitance dropped, and the circuit the capacitor was filtering stopped working. Hum bars rolled through the picture. The sound buzzed. The set ran hot. A capacitor checker measured both the capacitance and the leakage current, telling the repairman whether the component was within spec or shot. Unlike a tube, which plugged into a socket and could be swapped in seconds, a bad capacitor had to be unsoldered and replaced on the spot. Capacitor failures looked like a dozen other problems. The checker was how the repairman told the difference. Number 5, signal generator. A small box about the size of a lunchbox with a dial, a frequency selector, and an output cable. The signal generator injected a known test signal into different stages of the television's receiver chain. The tuner, the IF amplifiers, the video detector, the audio section. The repairman connected the output to one stage at a time and worked backward from the speaker or the screen until he found the stage where the signal stopped passing through. That was where the fault was. Without it, a dead television with no picture and no sound could be anything. With it, the repairman could isolate the failure to a single stage in under 5 minutes. Number 4, alignment tools. A set of tiny hex wrenches and screwdrivers made from nylon or fiberglass, each one sized to fit the adjustment slugs inside the IF transformers and oscillator coils. After replacing a tube in the IF strip, the circuit often needed realignment because the new tube had slightly different characteristics than the old one. The repairman connected his signal generator to the input. his VTVM to the output and turned the slugs a fraction of a turn at a time until the readings matched the specifications printed in the service manual for that exact model. A quarter turn too far, and the picture broke up or the color shifted. Alignment was the most delicate work the repairman performed, and these tiny plastic tools were the only things that could do it without detuning the coil by touching it with metal. Number 3, CRT Brightener, a small adapter that plugged between the picture tube and its socket. The brightener boosted the heater voltage to the cathode, which temporarily restored brightness to a tube that had weakened from years of use. A new picture tube could run $50 or more in 1965. That was more than 2 or 3 house calls combined. Most families couldn't afford the replacement. The brightener gave them another 6 months to a year of watchable picture for a few dollars. It wasn't a repair, it was a reprieve. The tube was still dying. But a brightener turned a dark, faded picture back into something the family could sit around after dinner, and for a lot of households that was enough. The repairman knew the tube was finished. The customer knew it too. The brightener was the agreement between them that finish didn't have to mean today. Number 2, Sam's Photofact. Not a tool, not an instrument. A printed folder published by Howard W. Sams and Company of Indianapolis for nearly every television model manufactured in America. Inside the folder was everything: the complete schematic diagram of the circuit, the correct voltage reading at every test point, the parts list with manufacturer part numbers and cross-references, the alignment procedure, a physical layout drawing showing where every component sat on the chassis, and the adjustment specifications for the picture tube and deflection circuits. The Photofact was the single most important thing in the Caddy, because without it, the repairman was guessing. He could measure voltages all day, but if he didn't know what the correct readings were supposed to be, the numbers were meaningless. 200 volts at a test point was either right or wrong, and only the Photofact knew which. Howard W. Sams published thousands of these folders starting in 1946. A repairman's file cabinet full of Photofacts was his library, his reference, and his edge over every other repairman in town. A new man in the trade bought Photofacts before he bought test equipment because the schematic was worth more than the meter. Number 1, Tube Caddy, the case itself, a hinge box covered in leatherette, usually black or brown, about the size of a large briefcase but deeper and heavier. Some opened from the top like a tool chest. Some had cabinet doors on the front. Inside, rows of square compartments held 30 to 50 replacement vacuum tubes, each one in its original cardboard box, sorted by type number. The common types had multiple spares. The rare ones had one. The rest of the Caddy held the soldering iron, the alignment tools, the test leads, the fuse box, the mirror, and whatever else the repairman had learned to carry over years of house calls. The Tube Caddy was not a container. It was the trade. When a man walked through your front door carrying one, you knew who he was and why he was there. Your mother let him in. Your father pointed at the television, and you sat on the floor and watched a man open a case and bring a dead machine back to life with a soldering iron and a box of glass tubes. Every American over 60 remembers that image. The case, the smell of hot solder and rosin, the click of a tube being seated in its socket, the moment the picture came back. The Tube Caddy disappeared because the tube disappeared. Transistors replaced tubes. Printed circuit boards replaced hand-wired chassis. When a solid-state television broke in the 1980s, you carried it to a shop or you threw it away and bought a new one. Nobody came to your house anymore. The man with the Caddy was gone, and the living room repair was gone with him. In 1965, the television was the most complicated machine in the average American home, and the man who fixed it carried everything he needed in one case, solved the problem before he left your living room, and charged you less than the cost of dinner for two. The house call died because the television got cheaper, and the repair got more expensive. It was easier to replace the machine than to fix it. And one day, nobody came to the door anymore. If you enjoyed this video, subscribe and watch the next video above.